Good day, this is Professor Will, CBMD PhD, and today's Tuesday, July 20th, 2021. It is 5:56 and 1 second p.m. Eastern Standard Time. Today's research, Glucagon. So let's hop to it here. Novel method for glucagon delivery. Date July 20th, 2021. Source, University of Notre Dame. A chemical and biomolecular engineer is rethinking the traditional use of glucagon as an emergency response by administering it as a preventive measure. For children with type 1 diabetes, the risk of experiencing severe hypoglycemic episode is especially common. And for parents, the threat of that happening in the middle of the night is especially frightening. And sudden and critical drops in blood sugar can go undetected overnight when the child is asleep, resulting in coma and death, an event known as dead in bed syndrome. A parent can check their child's glucose levels right before they go to bed, and everything looks fine. Then around 2 a.m., their blood sugar is dangerously low, near comatose level. Researchers had listened to parents of diabetic children describe the fear of such an episode, waking up several times a night to check the glucose levels in the panic of emergency situations, and rushing children to the hospital in the middle of the night. In several situations, glucagon injections can stabilize blood glucose levels long enough for parents to get their child medical attention. Researchers are rethinking the traditional use of glucagon as an emergency response by administering it as a preventive measure. Researchers illustrate how they successfully developed hydrogels that remain intact in the presence of glucose but slowly destabilize as levels drop, releasing glucagon into the system, raising glucose levels. In the field of glucose-responsive materials, the focus has typically been on managing insulin delivery to control spikes in blood sugar. There are two elements in blood glucose control. You don't want your blood sugar to be too high, and you don't want it to be too low. Researchers essentially engineered a control cycle using a hydrogel that breaks down when glucose levels drop to release glucagon as needed. The gels are water-based with a three-dimensional structure. Research describes them as having a mesh-like architecture, resembling a pile of spaghetti noodles, with glucagon sprinkled throughout. According to the study, in animal models, the gels dissolved as glucose levels dropped, eventually breaking down to release their glucagon contents. Ideally, in future applications, the gels would be administered each night before bed. If a hypoglycemic episode arose later on, 3 or 5 hours later, while the child is sleeping, then the technology would be there, ready to deploy the therapeutic, correct the glucose imbalance, and prevent a severe episode. Researchers emphasize that the research is in extremely early stages, and parents and individuals with type 1 diabetes should not expect to see such a therapeutic available in the near term. One of the big challenges was engineering the hydrogel to be stable, enough in the presence of glucose, and responsive enough in the absence of it. Another challenge was preventing the glucagon from leaking out the hydrogel's mesh-like structure. While the team was ultimately successful, research say they hope to improve stability and responsiveness with further study. Good day, this is Professor Will, CBMD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.